Okay, examples 7 and 8 deal with indirect measurement. And they talk about something called angle of elevation and angle of depression. An angle of elevation is an angle with a horizontal. So we have a horizontal line, and we think of this as being like our line of sight as we stand and look out straight ahead. And then when we raise our eyes to look up at something, that is called the angle of elevation. Okay, now if we put our eyes down to look at something, then the angle that it makes with a horizontal is called the angle of depression. So this is angle of elevation. And this would be angle of depression. Both the angle of elevation and the angle of depression are an angle where one of the sides is horizontal, okay, never vertical. So in example 7 here, we are trying to find the height of this flagpole. We stand 60 feet away from it and raise our eyes up to look at the top of the flagpole. We have an angle of elevation of 35 degrees. Okay, so if I have a leg of 60 and an angle of elevation of 35, and I want to find the other leg, then I'm going to use the tangent ratio because that has to do with both legs. So we're going to use tangent of 35 degrees is equal to the ratio of the opposite leg, which in this case is the height of the flagpole, to the adjacent leg, which is how far away from the flagpole we're standing, 60 feet. And we can now find out what the approximate tangent of 35 is by looking at our calculator. So tangent of 35 is about 0.7002 equals h over 60. And then we can just multiply both sides by 60 to get h. And we get h is approximately 42.01. So approximately 42.0 feet high. Okay, so now let's take a look at example 8, which has, I believe, an angle of depression. So on this one, we have a building that is 10 meters high. And if we were standing at the top of this, our eye is going out horizontal, and then we look down, we have an angle of depression. And that angle of depression is 22 degrees. Now, since the building is standing at a right angle, then we know if this is 22 degrees that this is complementary to it, which would be 68 degrees. Right? This angle down here is an alternate interior angle with 22, so this is 22 down here. It's also 22 because these two have to be complementary in a right triangle. Right, and we want to find out how long the wire has to be. The wire is X meters. The other side of the building is also 10 meters. So you can use either angle you want. I think I'm going to use 22 degrees. Then 10 is the opposite leg. And we're trying to find the hypotenuse. So the ratio that involves opposite and hypotenuse is the sine ratio. So the sine of our angle, 22 degrees, has to be equal to the ratio of the opposite leg, 10, to the hypotenuse, x. And the sine of 22 is approximately 0.3746 Alright, now you notice that x is in the denominator here, so we could multiply both sides by x, or I find it easier to just use your cross products property, think of it as a proportion. So we get 10 times 1 is equal to 0.3746 times x. And then to find x, we have to divide both sides by 0.3746. And we get x is approximately 10 divided by my previous answer, which was 0.3746. And we get approximately 26.7 meters. Alright, so there you have it. A couple of examples with angle of elevation and angle of depression. Good luck on your assignment.